Hello and welcome to this little video for mass movement, winds, and glaciers. We're going to be talking a little bit about the first two of these things, the mass movements and wind today, and then later on we'll talk about glaciers. So some of these things here, these main ideas for section 1. We're talking about how mass movements alter Earth's surface over time due to gravity, gravity moving sediments and rocks downslope. We'll talk a little bit about how wind modifies the landscape in all areas of the world by transporting sediments, and then how glaciers modify landscapes by eroding and depositing rocks. Okay, so we're going to start out with this one. This is all about mass movements. So these are the things that we want to talk about here in this section. What's the relationship between gravity and mass movement? What factors affect mass movements? What are the different types of mass movements and how are they described? And then finally, how do mass movements affect people? Okay, so a mass movement occurs when the forces pulling material down slope are greater than the material's resistance to sliding, flowing, or falling. So I'm gonna later on I'll show you a little diagram to kind of show how this happens. But basically what we've got going on here in all of these pictures of mass movements, we have this slide here, this like mud slide coming down, or a landslide coming down. Here's a rock fall and a rock fall. Gravity is always pulling on these things and trying to get them to go to a lower energy level. They're up high, they're at a higher energy level, they have more kinetic energy, but if we can get them to move down to a low area like a valley or a floor, then they'll have less potential energy, and less potential energy at that time. So gravity's always pulling on these things, but there's resistance to this pull. Friction is holding each other up, or the structure of the rock may be holding it up there. So mass movements, they occur when gravity is able to overcome those forces that are keeping the rock or the land in place. Now, one of the ways that does this is creep. Creep is the slow, steady downhill flow of loose, weathered earth materials, especially soil. So here in this picture here, we're looking at, this is a tree that originally when this tree started growing, it would have been growing straight up and down. That's the way trees grow, is straight up and down. But the soil underneath it here has moved downhill and caused all of these trees, you can see all of these trees, caused them to rotate out of their perpendicular, their straight up and down orientation to this downward leaning orientation. And then eventually the tree rights itself and continues to grow straight up. So this is evidence of soil creeping. Here's some more evidence of soil creeping when we get these little bulges in the soil. That's the soil slowly moving downhill. So creep is it's a very slow process. It takes weeks, months, years, decades to happen. But we see the evidence of these things as they happen. And like I said, it could be these trees showing us that it's evidence here, these bulges showing us evidence. You might have a power lines or fences that are out of skew because of creep. Now mud flows are swiftly moving mixtures of mud and water. And I have a little video to show you of this. We're not going to watch the whole thing, but I'll show you some of it here.
Stay here. Stay here. All right. Kill the engine. Kill the engine. Can we kill the engine? Watch that.
Okay, so that was a mudslide there coming down through the trees. Now mudslides, they happen when you have lots and lots of water, and the water mixes with the mud, and mud is like, you know, anything that's fine textured. And you could see that mud was just flowing super quick. There's videos all over the internet about mud flows. And these can be very dangerous. Of course, you saw the people that were in the boat. They were so close to that mudslide, barely got away. If they'd have stayed there any longer, they surely would have died from that mudslide there. So anyway, that's a mudslide. Next one is a landslide. Landslides are rapid downslope movement of earth materials that occurs when a relatively thin block of soil, rock, and or debris separates from the underlying bedrock. And I have another video here. So there you go. That's that rapid movement of rocks and soil coming down the hillside. That hillside just suddenly gave away and crushed the car down below. That's a landslide. Okay, a slump. A slump is this right here. So what we're looking at here, this is hillside, and the soil here becomes super saturated with water, and that supersaturation of water, this kind of gives away here. You get this scarp in the back, and then this slump block just kind of falls down. They're not traveling very far. They're just kind of going from a angle, like a steep angle, to a less steep angle. And then the last one that I want to show you here is avalanches. And an avalanche, you might think, what is this doing in in this section here? This is avalanches, snow moving, right? But it's still a mass movement of material. It's going to be moving snow and trees and rocks and boulders and all kinds of things that go along with it. So we'll watch this little video of avalanche.
With terrifying speed, an avalanche can rumble down a mountain slope, burying everything in its path under a lethal blanket of snow. Each year, about 150 people in Europe and North America die from avalanches. Large ones can wipe out forests and erase mountain villages. Avalanches come in many forms, some called slough, consist of sliding loose snow. Others, called slab avalanches, occur when large sections of the snowpack crack off and crash down the slope. As snow falls, it builds up layer upon layer. With enough time, the layers will harden and bond to one another. But when layers form weak bonds, any new snow falls on an unstable foundation and waits for the right trigger. Avalanches are caused by sudden changes, a heavy snowfall, strong winds, or a rapid change in temperature. The shape and angle of the slope are important factors. Slopes over 60 degrees are usually too steep. Slopes under 25 degrees are too gentle. The danger zone comes between 30 and 45 degrees. Just where people like to ski and sled. 90% of avalanche victims die because they or someone with them accidentally trigger an avalanche. Contrary to popular opinion, loud noises like yelling won't trigger an avalanche. In most cases, it's the sudden weight of a skier or snowmobiler that makes the surface unstable. Then the avalanche descends at speeds up to 80 miles an hour. As winter sports become more popular, avalanches pose more of a threat.
Okay, so that's an avalanche there. 80 miles an hour down that hillside, and there's no way that you could get away from that. So, very, very dangerous. I told you that I was gonna show you this little section here. So, usually, what happens in dry conditions, we have these grains, and these could be sand, silt, clay, pebbles, rocks, and they are all touching grain to grain. And so they get that grain to grain friction that's going to hold them in place. That's that dry conditions. But when we start to add water to that, so here we get this water that gets put into it here. You get this thin film of water, and that thin film can still hold those grains together. But if you get where water completely surrounds, the grains, if the water completely surrounds that grain, then there's no friction to hold those grains in place, and we get those slumps or the mudslides or the avalanche or the landslides, rock falls that happen at that point. So water is a huge trigger for making these mass movements happen. Okay, so just kind of reviewing that section there. Gravity is what directly causes mass movements. Factors that affect that mass movement are the slope, how much moisture there is, and usually we need some kind of a trigger to get them to start moving. The different types that we have: creep, mudslide, landslide, rock falls, avalanches. And how do they affect people? Well, they can destroy homes, properties, and some can even take people's lives if they're not careful.